Welcome to this overview of the Kony Push Notification Server, or KPNS. Push notifications are used to send data or messages from a server to a mobile device. Push is different from SMS in that the data is intended to be targeted at an application, not to the owner of the device. Push messages may contain text intended for the user, or they may contain data to update the status of an application. Use cases for push messages include notifying the user that an upgrade is available for an app, business notifications such as flight status changes, new emails, etc., promotional offers when a user enters a geographical zone, news feeds, sports scores, weather alerts, instant messages, social network updates, changes to enterprise data requiring a sync of the device, etc. Apple, Google, Research in Motion, and Microsoft all offer their own push networks for their respective mobile devices. Here's a sample of what push notifications look like on iPhone, Android, BlackBerry, and Windows Phone. KPNS makes push easier to implement. Use a single interface to send to any number of devices of any type. Use IDs that mean something to your business, such as customer number, rather than a complex hash that only means something to the mobile platform. You don't have to learn the idiosyncrasies of each platform. You can leverage all of the unique features of each push provider without compromise, while staying insulated from the details of their implementation. KPNS is reliable, automatically retrying until your push notifications are delivered. Your application is future-proofed. KPNS supports all of today's push providers, and when new push providers enter the market, your existing application will be compatible with minimal effort. KPNS can be clustered and can scale to support any number of requests and devices. KPNS validates requests before sending them to the push network in order to minimize the time and horsepower wasted on failed transmissions. And Kony Push Notification Service is flexible enough to accept push messages in XML, JSON, or key value pairs. You can initiate messages individually or upload messages in bulk. Let's now examine how KPNS works. We begin with the interaction between the device, KPNS, and the push provider. Phase 1, registering the device. Receiving push notifications is a two-phase process. In the first phase, the device must be registered with the push network and KPNS. Step 1 is for the mobile app to subscribe to the manufacturer's push notification service. Upon successful registration, the push provider returns an identification token to the device. Next, the mobile app sends a subscription request to KPNS along with the token it just received. KPNS returns with a subscription ID. The device is now able to receive push notifications. Phase 2 is how a push notification reaches the device. The push notification is initiated by a back-office process that determines that a message needs to be sent to the device. The sending process formats a request to send it to KPNS. Upon receipt, KPNS returns with a unique message identifier that can be used to query the status of the push notification. KPNS then validates the message, determines the type of device, and sends it to the appropriate push provider network. Finally, the push notification reaches the device. From the enterprise application's perspective, all device types from all manufacturers look the same. KPNS handles all the discovery and mediation. The JavaScript APIs are very simple and insulate the developer from the many differences between the different push providers. The first step is to set up callback functions for the various asynchronous push events such as registration success and receipt of a notification. Registering the device with the provider, no matter which type of device, uses the Kony.push.register function. In the callback from a successful call to Kony push register, we subscribe the app and device combination with KPNS, including the token received from the manufacturer. Now that the device and app are subscribed, which only needs to be done one time, we are ready to process inbound push notifications. We have two callbacks, one for when the app is running and another for when the app is not running. When the app is not running, the mobile operating system will still forward push notifications to our callback function. Kony Push Notification Server has a browser-based console that allows you to register push-enabled applications with each push provider, view and edit subscribed devices by application, manually post push notifications, upload bulk notifications, and view a complete audit trail of all KPNS interactions. To manually push to a device, you select the recipients, supply the platform-specific properties such as badges and sounds, enter the contents of the message, and click Push. On the Message Management tab, you can view the status of any and all notifications. The Subscribers tab lets you view the activities of any subscriber. Filtering makes it easy to find the subscribers that you are interested in. Similarly, filtering is available on the Message Management tab, allowing you to examine any particular message of interest. In the Subscribers view, you can see information about the subscribed device and the message status. In the Messages view, you can see the contents of the message. Here's two screenshots from an actual device. On the left, you see a KPNS test app that has received an online push notification. On the right, you see the same app, once registered, can receive offline notifications along with badges, sounds, and banners. Kony Push Notification Server gives you the ability to write once and push everywhere with ease. Thank you.